Dear students, today we are going to study the next lesson of alternating current. We have completed the introductory part. Today, let us apply the alternating voltage to a pure resistor. Okay, so today's topic is AC through pure resistor. Now, please do not wonder why I am saying pure resistor. There is nothing like pure inductor. There is nothing like impure resistor. There is nothing like pure resistor. We are just saying that we are going to consider only the resistance of this resistor. We neglect the resistance of this wire. That is why we call this as pure resistor. Okay, so let us consider this circuit in which we have got AC voltage and the resistor the value of whose resistance is R, and this is my AC voltage. Now I am saying AC voltage, and sometimes I also say AC current, but whenever I write it literally, it means AC voltage will be written as alternating current voltage, AC voltage alternating current voltage, and AC current will be AC means alternating current. It will look like that, but don't get worried about this term AC voltage and AC current eventually mean alternating voltage and alternating current, which is universally accepted in physics. So if I say AC voltage, don't laugh. If I say AC current, don't laugh. It is universally accepted for alternating voltage and alternating current. So let us apply this alternating voltage to this pure resistor. Okay, and here there are some terms which is V0, which is my peak value. Okay, peak value. Whose peak value? The peak value of voltage, or this can also be written as maximum value of voltage. Okay, alternating voltage, and the notation for this could be Vmax or Vm or V0. So these are the three notations to represent the peak value or maximum value of alternating voltage, but I prefer this V0 to or V0 to represent the maximum value. So these are the terms. Now one more term is there, which is omega t. What is omega t? It is a phase. Okay, phase, and this phase sometimes some author may write phase angle. Okay, or some book may only write the phase and some book may write phase angle. So here I am writing phase angle. Now what is omega here then? Let us define this. Omega is angular frequency, and whose value, that is omega equal to 2 pi f, which is equal to 2 pi by t, because frequency f is equal to 1 by capital T. So what is capital T? Is the time period. Okay, we have studied this in class 11 also, and in class 12 we have studied this in the cyclotron and the charged particle rotating in a circular motion, that we have studied. So these are my some quantities. What is T? T is the time. Okay, that everyone knows. So let me rub this out. So as I have applied AC voltage to this resistor, then what should be the value of alternating current in this resistor? Okay, so let us find, our job is to find the alternating current over here, the equation for alternating current. This is given. Okay, now we know that V is equal to I into R. Okay, from the Ohm's law. Again I will tell you why I am writing small letter V and small letter I. Whenever we deal with the alternating current and alternating voltage, we represent it by small letter I and small letter V. But for DC, we represent it with capitals. So I want to find the equation of I. From this, what do I get? There is V. I will bring this R down, will be equal to I. So I is equal to V by R. Okay. So let me write this as equation number 1 here only, or I can also write it over here. So implies this, I want to find the equation of I, so I will be equal to V divided by I. What is the value of V? It's V0 sine omega t divided by R from this equation, and this equation V0 by R, this can be written as I is equal to I0 sine omega t. What is I0 is V0 divided by R. See, what is the equation of current? The equation of current, I is equal to V divided by R. If I divide voltage by R, I will get the current. Similarly, if I divide voltage by R, I should get the current. But there is V0. It means if I divide maximum voltage by this resistance R, then I should get I0. Okay, V by R is I, V0 by R is I0. So I got the equation of I. So let me write here. What are the equation that we have got is this V is equal to V0 sine omega t, equation number say 1. I is equal to I0 sine of omega t, equation number 2. So we got these two equations. Okay, we got the value of current whenever we apply alternating voltage to the resistor. Now let us see, there is a very interesting thing to see over here. This is phase angle, isn't it? Now if I see here in voltage and in current, the theta, the angle of sine is omega t here, the angle of sine is omega t here. It means that the phase angle, which is my omega t, okay, what is this? Omega t is my phase angle, okay, phase angle. Is there any difference between phase angle between the current and the voltage when it passes through this resistor? No. Why? Because the phase angle is omega t in both the cases. So number one quantity that we should understand here is very important, that there is no phase difference. Okay, there is no phase difference between voltage and current. Okay, whenever you write it in the copy, please write this V and I in its full length. Okay, when it happened, when alternating AC voltage or AC current passes through what? Passes through pure resistor. Okay, this is very important point. Whenever alternating current or alternating voltage passes through a pure resistor, there is no phase difference between current and the voltage. So there is phase difference. Okay, phase difference can be denoted by delta, small letter, or phi. Okay, some book will write small letter delta and some book will write phi. Delta and phi are phase difference. So what is delta here? I would write this phase difference phi is equal to 0 when a alternating current passes through a pure resistor. Okay, so this is done. Now let us represent this in the graphical form. Let us represent the voltage and the current in the graphical form when it passes through a pure resistor. So I will write this. So this is my omega t. This axis is my omega t, and this axis is my voltage or current. This axis is also my voltage or current. It could be both, and this is my 0. Okay, so let me draw it here like this. Why I am doing like this? Okay, so let me make it a smaller one, quite a smaller one. Okay, so this is my V. So this red graph is my V, and this maximum value is V0, okay, which is at this point. At this point, the value of voltage is maximum, that is V0. So the red is for voltage. Okay, this red, I will write it here. Red is for voltage. Okay, so this is my omega t. So this value is actually my pi by 2, and this value is my pi, and this value is my 3 pi by 2, and this value is my say 2 pi, and so on. Okay, so how I am getting pi by 2, pi, 3 pi by 2, and 2 pi here? Actually, this is my half circle, this is my half circle, not half circle, but this is my half cycle, this is my half cycle. So whenever I take this here, then it will become like this. Okay, from this point to this point, it will take a time to travel. If the voltage is traveling with respect to time, whenever it start from 0, it will go and reach here to t. It will make a complete cycle, isn't it? Started from here and ended here. So this is making a complete cycle t. Why I am writing t is just because this I wanted to explain why I am writing this pi, 3 pi by 2 and 2 pi, etc. So this will be how much value? This will be t by 2. Okay, this will be t by 4. Okay, quarter time, half time, t by 2, and this is full time. So I am getting these values here. So we have to put this value omega t, isn't it? This pi by 2, pi, 3 pi by 2 and 2 pi are the values of omega t. And we know the omega is 2 pi divided by capital T into small letter t. Okay, so I will write here 2 pi by t. At this point, what is the value of time? It is 0. So this will become 0. This is equal to 0. So here is 0. Now at this point, what is the value of omega t? Again, omega t is 2 pi by capital T into time is there. What is the value of time at this point? Is t by 4, isn't it? I will write t divided by 4, and this t will cancel, and this pi, this 2 to the 4, it will give pi by 2. So I am getting here pi by 2. Similarly, again I will write 2 pi by t into this t. What is the value of t here? T is t by 2, isn't it? And now this 2 and 2 cancels, t and t cancels, I get pi. So this is what I am getting the values of 0, pi by 2, pi, 3 pi by 2 and 2 pi, so on. Okay, so this is the way how you can write it. Okay, there is one more interesting thing, easy way to remember these values. So just remember like this: 0 pi by 2, okay, 1 pi by 2, 2 pi by 2, 3 pi by 2, 4 pi by 2, 5 pi by 2 and so on. 0 pi by 2 is 0, 1 pi by 2 is pi by 2, 2 cancels, it will become 2, it will become 3 pi by 2, okay, 2 cannot cancel this, and 2 to the 4, so it will become 2 pi and 5 pi by 2. So this is how you can also remember: 0 pi by 2, 1 pi by 2, 2 pi by 2, 3 pi by 2, 4 pi by 2 and 5 pi by 2 and so on. Then this is the value. 0 is here, pi by 2, pi, 3 pi and 2 pi and so on. So we got this value. So this red is for voltage. Now let us go to the current. So I will draw the current with this blue. This blue is my current, and this will go up here, and the maximum value of the current is here, I0. Okay, so this red, this and blue is current. Now we have done the representation of current and voltage in the graphical form. Why I am doing with this kind of graph? Because I have got the sine, and sine function will give the graph like this. Therefore I am getting the sinusoidal curve for current and the voltage. Okay, so there is one more interesting thing, that remember, voltage will be always higher than the current. Voltage is always higher than the current, because in any circuit voltage is larger than current. Why? Because we know that V is equal to I into R. Okay, suppose if V is 10, and this is equal, then this has to be 10, because there is equal sign, and I will write this as 5 into 2, 5 to the 10, so this is equal. What is the value of I? Is 5, value of R is 2, and value of V is 10. Now tell me which is large. 10 is of course larger than 5, therefore the voltage is always larger than current in this case from this equation, that is Ohm's law equation, right? So this is all about our current and the voltage representation. Now if we see here, at 0 the current started from 0 and the voltage also started from 0. That is one noticing point. Another point, at this point, if I drop it down at pi by 2, what is the value of current and voltage? At pi by 2, the current is maximum. At pi by 2, voltage is also maximum. Okay, it means why at pi by 2 current and the voltage are becoming maximum, because they have no phase difference. Okay, this is the reason why the maximum current and maximum voltage at lying at the same point, that is pi by 2. It is just because they don't have any phase difference. Okay, so looking at this graph, this type of graph, looking just this type of graph, we can actually say what is the phase difference. They have started from 0 and 0, that is there is no phase difference. Another way to say is that the maximum current and the maximum voltage are in the same point, that is they don't have any phase difference. So this is the significance of the phase difference. So we say, we have already said, whenever alternating current passes through a resistor, there will be no phase difference between voltage and the current. So next is, let me find the power. Okay, power. So this power has got some special name which is called instantaneous power. Okay, instantaneous power. So let us calculate instantaneous. Please write this in the full: INSTANTANEOUS, instantaneous power. So to calculate the instantaneous power, what I mean is, this resistor must be consuming some power. Okay, so let us find that power. The formula for power P is equal to V into I, or small letter v and small letter I, no problem. From the class 10th, we have understood that power is equal to V I. There is one more formula of power, which is I square R, and so on. So let us put the value of power V and I. What is the value of V? Is V0 sin omega t. What is the value of I? I0 sin omega t. This will give me V0 I0 sin square omega t, because there is 2 sin omega t. So sin omega t into sin omega t is sin square omega t. So we got the power P. Okay, now see, there is sin square. Okay, so sin square is the value which is quite difficult to calculate. Okay, so we want to convert this square into non-square form. So how to convert? We convert it by using a trigonometric identity. So we have got one formula: sin square A is equal to 1 minus cos 2A divided by 2. So this is the formula. What is the formula? Sin square A, 1 minus cos 2A by 2. Okay, so P then will be equal to V0, I0 is there, and I will open the bracket here. Sin square omega t, sin square A, so it will become 1 minus cos 2. What is the value of A here? A is omega t, divided by 2. Now there is no power in the formula. Okay, so there is no power in the formula. So let us solve it little more. Then I will get V0 I0 divided by 2 minus V0 I0 divided by 2. Okay, and cos 2 omega t. So this is the formula for instantaneous power. So let me write the formula of power here. The formula of power is V0 I0 by 2 minus V0 I0 by 2 cos 2 omega t. So this is the instantaneous power. Okay, we have just simplified it, no worries. Now, okay, so there is one problem with this equation, because whenever we buy an electric bulb, any electric instrument, we say I have got the bulb of 60 watt, I have got the bulb of 100 watt, I have got an LED bulb of 8 watt. What I am saying is, in each and every sentence I am saying a particular value of power. 60 watt is a particular fixed value, 550 watt fixed value, 60 watt fixed value, 100 watt fixed value, 8 watt fixed value. So the power that we refer in daily life, the power that we use in daily life have got the fixed value. But if I see here in this equation, there is time and cost. So if I have cost, leave the cost. If we don't want to think about cost, then let us go to the time. Whenever electric current, AC current passes through any device, then the time will keep on changing. If the time keeps on changing, then power should also change. Okay, so we are calculating here the instantaneous. At 10 seconds of time, what will be the power? At 10 seconds, the power is different. At 20 seconds of time, the power will be different. That is why we call this as instantaneous power. But whenever we calculate, we say a particular power, 100 watt, okay, 40 watt, etc. So what is that power? What kind of power do we are referring? So we are referring an particular power which is called an average power. So the instantaneous power has less use in daily life. The most useful power is average power. So let us calculate the average power over here. Okay, average power. So average power, please write it in full. Okay, so average power, how can we denote it? We can denote it by this bracket or PAV. So both are same. This is also average power, this is also average power, and I prefer to write this kind of stuff here. So how do I get average power? This is average. We have studied in class 11 how to calculate average. Minus V0 I0 by 2 cos 2 omega t, and this is the power. Okay, now in the second step, what we write is, I will write it here only, but we will have to write it in the second step. So there are two terms, so I have to do it like this. This is in the second step. Okay, now in third step, what we do is, if you see here, V0 is a constant value, I0 it is also a constant value, 2 is a constant value, so we don't need to take the average of constant. So average of constant value cannot be taken. Now let us go to here. V0 is also constant, I0 is also constant, 2 is also constant. So we don't take the average of this. We take the average of this cos 2 omega t only. So this is the average value. Okay. So how to take the average value of cos 2 omega t? Okay. The average value of cos 2 omega t or average value of sin 2 omega t will become 0. Very simple now. Now, is there any way to show that the average value of cos 2 omega t is equal to 0? I am directly saying yes, it is 0. But is there any analytical way? Yes, there is one analytical way. We can actually prove it, but I don't prove it here. It will take long time. If I want to prove it, then there is one formula in trigonometry. This will be equal to 1 by capital T 0 to capital T cos 2 omega t dt. If I solve this trigonometric integral, then I should get this will be equal to exactly 0. So this is the formula to take average of cos and sin. Okay, instead of cos, if I had a sin 2 omega t, then also it should give me 0. So I got the average power very easily. So if this is 0, then this term, whole term will become 0. Then P average I will got V0 and I0 divided by 2. So power average, let me write here. Average power, the value of average power that we got here, P average is equal to V0 I0 by 2. Okay, so this is the power that we actually measure in any electrical component when AC passes through it. So this has got very important significance. Okay, so one more problem is there. Whenever I say that I am getting 240 volt of alternating voltage, I say I am getting 2 ampere of alternating current. Okay, what I am doing is, if I say 250 voltage of alternating current, 250 voltage, it is also a particular value. 250 is particular value. But if I see in the graph here, then what do I see? It started from 0 and it keep on increasing and it reaches the maximum value V0. And again it decreases to 0 and it went into the negative part and again into the 0. This line is 0. So which value I am referring to? I am saying 240 volt, 250 voltage. Which value is that? Is that this V maximum? No, we do not measure V maximum. We measure root mean square value. Okay, like the power. In power, we only measure the average. And current and voltage, we measure root mean square value. Let us find that. Okay. So just write, in any electrical circuit, we don't measure the peak value of current and voltage we only measure the RMS value, that is root mean square value. So let me solve it to get the root mean square value. So this can be power average can be written as V0 by root 2 into I0 by root 2. Can I write? Yes, root 2 into root 2 is equal to 2. Okay, root 2 into root 2 will give me the same thing. And this value is called VRMS and IRMS. Okay, so this is equal to VRMS into IRMS. So we measure VRMS and IRMS. Root mean square value of current and root mean square value of voltage. Okay, so what are VRMS and IRMS? Then VRMS is equal to how much? This is V0 by root 2. Okay, what is the value of root 2? Root 2 is 1.414. 1 divided by 1.414 will be giving me 0.707 V0. Similarly, IRMS is equal to 0.707 I0. So these are the values that we measure in daily life. Okay, any measuring instrument, if I have a multimeter by using which I wanted to measure the alternating voltage and alternating current, then I will be measuring VRMS and IRMS, not the V0 and I0. Very interesting point of this one. And these are the values of VRMS and values of IRMS. Now see, I am dividing V0 by root 2 and I am dividing, similarly I am dividing I0 by root 2 to get IRMS. It means that the values of VRMS and IRMS are quite lesser than V0 and I0. Okay, so for that I will write it here. Somewhere here, which is less than peak value, is my VRMS. Somewhere here, which is less than peak value of current, is my IRMS. So these are the values which we are measuring in daily life. So we got the powers and IRMS and VRMS. Okay, so everything is done. Now let us go to the something called power. Okay, let us find the power over here. The graph of power in this graph. Okay, so power co-graph. How to calculate? The formula of power that we have done is P equal to simply V into I. Okay, in this part, what is the value of voltage? It is positive or negative? It is positive. What is the value of current? Also positive. Now if I multiply positive and positive, I should get the positive value. So there I will get this as the power. This is the power, and it's at the maximum. Okay, it will be more higher than voltage because I am multiplying the two quantities, right? This and this. Of course, it will be more than V and R. Okay. Now in here, the current is negative, voltage is also negative, below the 0. This is negative into negative. What will give me? Again it will give me positive. So the power for this cycle will also go here. So this is my power. Very simple. Okay, why it is going above? Why it is in the positive side? Because here positive, voltage is also positive, current is also positive. Answer will be positive because the power is V into I. Here V is negative, current is also negative, negative into negative, positive, and the power is this. Now lastly, let us go to the phasor diagram, right? So this video is going to be a longer one. So last is phasor diagram. What is phasor diagram? Phasor diagram is representation of current and voltage in the form of some vectors. So we can also draw the phasor diagram just here, but that will be meshed with this one. Okay, it may not look good, so I am drawing it somewhere here in the separate part. Okay, so this is my, so this is omega t. Okay, what is this? This could be my voltage or current. So this one is also voltage or current, no problem, and this is 0. Okay, so to draw the phasor diagram, I will draw one arrow like this. This is V. Okay, and I will draw like this. There is omega t. Okay, this value from this axis, because of there is omega t, so I will write this as omega t, which is angle, phase angle. Okay, so this is V vector. Phasor diagram, in phasor diagram we represent the current and voltage in terms of what? In terms of vector. Therefore this value, okay, this value, what is this? Okay, so this value is my V, okay, the voltage. Now very interesting thing, there is one interesting way to draw it. Whenever we draw the phasor diagram, we have to consider the phase difference, phase angle. So what is the phase angle or the phase difference between voltage and the current when the current passes through a pure resistor? Phi is 0. Whenever the phi is 0, then current and the voltage lie in the same line. So I will again draw another arrow here, which is my I. So this is my value, this value is I, okay, I. Now the two vectors, that is I vector and V vector, are in the same line. Why they are in the same line? Because they don't have any phase difference. Now if there was a phase difference, if current and the voltage had a phase difference, then the line of current represented by blue arrow and the line of voltage represented by red arrow would not lie in the same line. Okay, one would be looking like this. If there was phase difference, then it should look like this, or it should be looking like this. Okay, since there is no phase difference, they are lying in the same time. So lastly but not the least, very important, let us discuss the question from this part. Now basically sometime it is asked that you will be given this diagram, phasor diagram, and you will be asked to find for what situation this diagram refers to, correspond to. Now if I see voltage and the current are in the same line, that is there is no phase difference, phi is 0 here, phi is equal to 0, or delta is equal to 0. Okay, phase difference is denoted by delta and phi because they are in the same line. Now when there is no phase difference, in which situation? The situation is that when current AC, that is AC current, passes through pure resistor, there is no phase difference. That is, this must be the diagram, phasor diagram for a pure resistor when AC passes through it. Another, similarly, this diagram would be given and you will be asked for what situation this plot, VI plot, represents to. Then if I see at pi by 2, this point, the maximum current is I0, at pi by 2, maximum voltage is V. It means at the same point, that is pi by 2, there is maximum current, at the same point pi by 2, there is maximum voltage. Why there is having maximum voltage and maximum current at the same time? Because there is no phase difference. And when there will be no phase difference? When AC passes through a pure resistor. So this diagram refer to this situation. Okay, we have to write like this, and there is some more power is also there. Please remember this diagram very correctly. So with this we end this topic. Now in the next lesson we are going to apply this AC voltage or AC current to an inductor, and we see what will happen there. Thank you.